All right, let's get started. It throws me off every single time when the song changes right at the beginning of lecture. All right, so we're still in votes week, I labeled as review. So let's collapse this. And then the one time it doesn't do it. Take a look just to make sure there wasn't some last minute change. Hopefully not, because what I prepared will be completely shot then. But showcasing stuff the way that we did on the homework, that's what we did on Monday. Not sure if it'll be interesting. It will be interesting, by the way, but maybe DDoS attacks and server spam prevention would like to be covered. We covered most types of attacks, but not this one. And yeah, this is something I never really talked about in a 312. I'm happy to see this one voted because I never really even thought about it. So this is what I prepped today. We're going to talk about DDoS attacks and talk about what that even is. This is a type of attack that's becoming ever more popular these days. So I think it's a pretty relevant topic that's just growing in relevancy. So that's what we got here. Let's see if there are any crazy things here. Thank you for not upvoting politics, by the way. I don't know how I would approach that one. It'd be a tough one. Hacking the government databases. And the next, I think this was the highest voted one, hosting a Minecraft Bedrock dedicated server inside a Docker container, which is unless something very disruptive with the voting, let's see here. Devu would have been fun. It would have been fun for me, probably not for anyone else. And TA shouldn't get a vote anyway. So no crazy surprises down there. So this is my plan for Friday, is to host a Minecraft server in a Docker container. So why not? That's what was voted. That's what we'll do. So, DDoS attacks. Let's do this. Where do I want to start? I have my notes. I'm going to try to not refer to my notes. I can remember everything. So, a DDoS attack, we're not ready to talk about quite yet. We'll get there. But let's start with a DOS attack. So DOS attack is a denial of service attack. The idea is to flood a server with something, in our case right now, HTTP requests, but flood the server in a way that the server can't handle actual users. So you're giving it so much traffic or so much bandwidth or so much to compute that the server can't do its job. So this is used as a way to take down a site. If there's a site doing something that someone doesn't like, I don't know, they'll launch a DOS attack and try to take that site down so legitimate users can't use the site. Which, don't do that. Like, come on. But I'm going to show you what it's all about. So here's a DOS attack. I'm going to CSE312.com. This is a DOS attack, actually a DDoS attack that you all launch on Autolab all the time. Is you mash refresh. You're sending a whole bunch of requests to the server. The server has to handle all those requests. If enough people do that on a server, like Autolab, when you're waiting for your results, your feedback, you just mash refresh. That sends a lot of load to the server, and if the server can't keep up, then it can take the service down for everyone, which is a flaw with Autolab. I'm not blaming anyone for that. I do the same thing when I'm testing my assignments. That's something that needs to be fixed in Autolab, where it actually just says, hey, your results are ready, instead of making you implement your own rudimentary polling system by mashing refresh. But it is can technically be a DOS attack. If there's a really crappy server, that might be enough to take it down. So that's the idea, is we're going to flood the server and make it so it's not able to handle legitimate requests. So what I want to do is run my server. Nginx. Web server from TCP, and of course, Docker's not running. I caught it before, though. So I'm going to run Docker and run this inside my Docker container. Can I just run? I think I have this set up where I can just run the app without Docker, actually. I'll do it that way if I have it set up that way. Because Docker it's taking all my resources. Docker's DOS on my laptop every time I start it. Seriously, Docker I have no control right now. There we go. Which you are all, I'm sure, familiar with, the amount of resources Docker takes up. At least with Docker, I don't get mad at it, because Docker has to do a lot. It's, simulating entire machines on my laptop. So I can forgive Docker. I can't forgive Chrome and Chromium browsers. So let's quit Docker Desktop. It's running port 8000. Localhost 8000. And there's my app. Yay. My beautiful app. And what I'm doing running this app is printing out every request that I get. And I'm just going to grab one of these and get it in my clipboard. Here's the request for the root path. So if I send a request for the root path, I should get the HTML for my site. And what I want to do, which will take a little bit to set up, is try to launch a DOS attack on my server. I don't know if I'll be successful. I can if I really break it, but I want to show you the ideas, the concepts behind this. So what I'm going to do is something that I probably should do. Maybe someday will be just part of 3.12. But what I want to do is write a TCP client. So we write TCP servers all semester, but we can actually use that same idea to write a TCP client, which is what your browser is. Your browser, underneath the hood, uses probably libraries, but it does initiate the TCP connections and connects to our server and then starts sending bytes over that connection. So for that, I'm going to import socket. I'm going to open a new socket connection with socket.socket as socket. No, I can't call it socket. As connection.connect. And this is going to take a host and port. So if our server is listening, like my server is listening on localhost 8000, the socket's going to need that host and port to know where to connect. So, and I think I can just, hopefully I don't forget things along the way. Address union of tuple string bytes. Okay, so localhost. Does it want it like this? No. Yeah, I think it wants it like this. Let me just test. I thought I memorized all this, but if not, if we gotta look some things up, we'll look things up. And then connection.sendAll. Just like on your server side, when you're sending all to the client, we have the same thing. And I'm going to send all that request that I copied from the terminal. So I'm going to take a legitimate looking request. This was generated from my browser, and this is all your code sees, this is all your server sees, is that HTTP request. I'm going to send an HTTP request from my own TCP connection, and it's just going to happen to look exactly like a request that comes from a browser. And the server isn't going to know the difference. So I'm completely spoofing a request that came from my browser, but just doing it in a different way. And then I'm going to wait for a response. So I'm going to receive, let's say, 5,000, however many bytes. My received data. And then I'll print that data to the screen. So just a simple proof of concept, which hopefully will work. I think I got the syntax wrong here, but let's see. And let's run this thing. Must be a tuple, not a string. Oh, yeah. Okay. A tuple, not a string. $8,000. Is there a different syntax for tuple specifically in Python? Parentheses for tuple. Thank you. Okay, let's try this again. There we go. So we're printing out the response. We got content length 2218. If we scroll enough, we're going to see our HTML. The server just saw this as a legitimate request, checked the path, served whatever it hosts on that path, sent me the data just like I'm a browser. The difference, of course, is that I can change anything in here. Like in your browser console, you have a lot of control over things. And if that's not enough control, you can go to Postman and control things there as well. You have a lot of control over what you do. But if you want even more than that, specifically if you want to do something malicious, you can just write byte for byte your exact requests that you're going to send. So I'm going to write byte for byte what I want my request to be, and then have that be my exact request. If I want to go to my cookies, which I don't think I have any set right now, but if I do, if I don't, we'll just have to simulate it. I don't have any cookies set, but if I wanted to set some cookies, I just add that header in here. We know how cookies work. It's just a header, right? I'm just going to literally type out the cookies. I go to my roommate's laptop. I check what those cookies are. I copy and paste them onto a text file on a flash drive that I have. I pull that out, put it right here, type in that cookie. Of course, you can do that right in the browser too anyway. Type in that cookie in my request right here. And I'm sending a request as that user. Any request that I want, any method that I want, I can make this a post request. So let's go over to my server. I can make this any request I want. Let's go to my server and add a, let's just do it. That's going to be too much data. We could do an image and we can mess with that, but let's just do a registration. Page is not working. It's probably because I didn't run it in Docker, so I don't have a database. Don't worry, don't panic. Everything's fine. Oh, shoot. Yeah. It really broke, though. All right. Let's do an image. Oh, this is going to be broken too, though. Then. All right. Let's do this. I think this endpoint here doesn't do anything if I remember, which means it shouldn't break. Oh, and I do have a cookie now. Okay, so let's get that request. If I can find it. Right here. Let's get this post request. Because what a post request has is content. It has a body. It has things that's actually sending. So let me back up a little bit actually. Because we're talking about DOS attacks. So this is how we can set up a TCP client. That's fine and good and everything. But if we want to send a DOS attack, let's not do well true. I don't want to do that. For I in range of 100, I don't need those parentheses in Python. A pretty important piece of white space right there. Now I'm just going to fire out this request 100 times as fast as possible. And let's ignore the responses. I'm going to send this. I'm going to look at my server. Oops, I don't want text wrap. I wanted this one. Did that run? What do we got? What do we got going on here? Did it just do it that fast? No, it didn't. What do we got going on here? This is not where I expected the demo to break. We're still at the easy stuff. For I in range, send all. Did I completely break it? Want these? The counter 19. I think it is going. Counter 20. We get 1. How come I'm not getting my loop? Did I just forget how to do loops in Python? It's possible. We get 21. We do get 1 request sent. I don't want to sleep. So if I sleep, I can. Let's try that just to see. How do I sleep in Python? Okay. Okay, we'll try to sleep, but we don't want to sleep because if we sleep too long, that's just like hitting refresh in our browser. Like we can hit refresh pretty fast. The idea is that we want to fire off requests ridiculously fast. So it has a better chance of actually plugging up the server. So connection, broken pipe. Maybe that did do it. Let's try to go 10. Let's try to ease this off a little bit. Let's just try 1 and see if my code's completely broken. So we did send some. Let's go 2. Can I not just send all? Do I hear 3? This is how hackers do it. Broken pipe. Maybe I do have to receive. So let's actually receive the data back. No, my server just doesn't like. I have a way that's going to do it. Get rid of this. Let's get rid of this. Let's put the whole damn thing in a loop. So we're going to create a new connection every time. This should definitely do it. Now I want to crank this up to 100. And now my server is going to not like this. So now it's not just another request each time, it's a whole nother connection. It's a little bit more overhead. And my server's got a lot of work to do. It's got to handle all of these requests. And if my server's not handling it too well, if I'm not handling requests in a really efficient way, hell, even now, like if somebody sent a request somewhere during this, there's a bit of delay here. I mean, some of that's going to be the TCP handshake because these aren't in parallel. But still, my server is doing a lot of work now. So it's going to take a while for a legitimate user to be able to get their connection in. And if I can, I should have... I always forget the syntax. This one I didn't plan on doing during lecture, but I should have since it's a DOS lecture. But let's see if I can remember off the top of my head how async works in Python. If I create an async function, async def, I'm mixing too many languages in my head. Connect. But doing multi-threading in Python is always giving me trouble. It's not as intuitive as I want it to be. Or maybe it is and I just always did it wrong. where we're at. We're almost done with that. My server's almost done with those posts. All right, and let's run this again. Yeah, that's what I thought. What's an async function? An asynchronous function. So I want these to run concurrently. But it wants me to await, which makes it strictly not concurrent. And I struggle with this. A TA and I were actually trying to figure this out before. To get Python to run async methods asynchronously, I didn't think would be really hard, but I remember it being more difficult than I wanted it to be. I don't really want to multi-thread. But if that's what we got to do, let's do it that way. Import multi-threading. I'll give up on this line pretty quick, though. Import multi-threading. Well, come on. If you don't even know the package name, how are you going to walk me through the whole thing? Come on. If you don't know how to do it, don't throw things out like that. So I'm going to give up on that. But the idea is you can do things asynchronously. Maybe I should have done this in JavaScript. It's trivial in JavaScript. So let's get rid of this. We have our loop. Actually, I don't even want to use my loop now. So that's one thing. That's fine, but that's not going to take down any servers. It's really not going to hurt anybody. So let's do this in a different way. Let's get smarter about our attack and take advantage of how servers work. Oh my goodness, so why can't I think? There we go. So now, which probably isn't going to be in my clipboard anymore. I think I got rid of it. But I want to grab that post request that, it's going to be way up there. Let me go to the browser and send another post request. And let's send a better attack. Let's go over here. Let's get that post request. Which does say uh-oh, but it didn't crash, so I'm okay with that. Let's paste it here. And I'm going to send this post request and do the same thing. Oh, there's my keyboard shortcut. I'm going to keep my loop. I'm too lazy to retype it. I'm just going to pass. So I'm sending a post request. We're doing the same thing. I'm going to send it. Did the same thing that the server does. Just gets the request and handles it, sends a response. I'm not even listening for the response, but it's sent. It does the same thing as the browser does. Now, if I really want to launch a DOS attack, here's where we start getting into some things where we can exploit things that you know about from this course. I'm sending 247 bytes to the server. What would your server do if this was 248? Probably going to get stuck in an infinite loop, right? I think mine will. So now I send this request, and my server's stuck in an infinite loop in there, waiting, buffering to get that content link number of bytes. My process already finished. It sent off the request. I'm not listening for a response. It's done. I do this in a loop. Now my server will still work. Maybe. Okay, it still works. But I'm using, like you're using, threading TCP server. So it is still costing me, I don't know for sure about this one, but it should, oh, and there's the tuple syntax. It is the same syntax we used for this. But this might be using, I'll hedge a little bit here, it might be using one thread per connection. So if I keep launching those connections, I can keep getting more and more threads all gummed up, doing nothing, just sitting in that infinite loop, waiting for the rest of the content that's never going to get there. And if I do this enough, let's try 1,000. This one might start plugging up my server. Now, legitimate user tries to go to the site. Oh, it's actually handling it pretty good. It's going to start using up those resources. So let's restart the server, just so we can at least watch a server die. Let's restart the server without threading. We'll just use an unthreaded TCP server, which it's single-threaded, so it's only handling one connection at a time. Let's do this. Server run. A legitimate user is going to be able to use this app. And if I have several legitimate users, they're going to be able to use it simultaneously. Not really, literally simultaneously, but they'll be able to use the app. The server just has to respond to each request one at a time. But once I launch my DOS attack, and I say, no, that thread is mine. I get that thread. And I'm going to get you stuck in an infinite loop. And then, oh, come on. Okay, yeah, I think I know what's happening here. And then here's where we'll do time.sleep. 10 seconds. Because once we get to the end of this block, actually, I wonder if I just don't gracefully close the connection. But once I get to the end of this block, the connection's going to be gracefully closed, and then the browser, the server says, oh, whoa, that TCP connection's closed, let me clean things up, and then gets out of that loop. I believe that's what's happening here. So let's spend more than 10 seconds. I think that might have done it. Oh, because it's 10 seconds inside the loop. That's 100 seconds. Why is my server so robust? You're supposed to break today. This is the one time I want my code to break. I hate being embarrassed by code that works. But that's the idea behind that. But so, it's talking about preventions. Let's start talking about preventions here. Is the first big line of defense is timeouts. So you're in your infinite loop. Instead of just looping infinitely until received bytes equals content length, instead of doing that, you would have some additional check there. Or it's been too long. You have some timeout interval and say, hey, if I haven't received any data in, say, like a full second or several seconds, whatever you want your timeout to be, which would be a big parameter to adjust. You don't want it too short, or somebody with a slow internet connection might not be able to use your service. But you don't want it too long, because that's going to make the DOS attacks more effective. So what DOS attacks are going to do is say, nah, I'm going to send 10,000 bytes. And then in the body, we can send all this information. That's fine. We can leave it like that. And then I'm going to have my loop. I'll leave this loop here too. But for j in range of a whole bunch, what I'm going to do is just drip feed the data. I'm just going to drip feed data to the server. At an interval that's not going to trip the timeout. like a send, and just send. Maybe that's where I'm going wrong. Let's restart the server too. Something might have got borked at some point. I shouldn't have done this as a demo. I should have just talked about it. Connection dot send more data. Why would the pipe be broken? Why is my server getting that request and then saying, nah, it should still be buffering my content length? Let's decrease this. I don't think that's what's doing it though. Maybe it is this uh-oh that we're hitting. All right, whatever. I'm still going to talk about it. So this is what's called I forgot what it's called too. I think it's slow post. That's why I called the file that. But I think it has a fancier name than that. But we're slowly sending data. We're just going to drip feed data. We're just going to send a few bytes at a time, down to 1 byte, and then send a byte at regular intervals. So instead of having that timeout trigger, it's going to say, well, the connection's still sending us data. Let's wait for this data. And then you have several connections open like that. You can keep drip feeding data to the server, and the server has to use up resources to be able to handle each one of those requests. Yep. That's the big question. It just in general, how do you distinguish an attack like this from a legitimate user, especially when the attackers are trying to disguise these more and more? So whatever, like your slowest legitimate user, whatever that traffic looks like, an attacker is going to try to simulate that, make their attack look like that, and what do? I don't know. That's an excellent question. And this is this is happening recently. There was just a DOS attack that made the news last month. These are happening. This is a big method of attack that's happening to take down sites. Even major sites, every once in a while, they'll have a DOS attack, they'll have some outage, and they got to try to update their defenses and try to account for that. It's a tough one. This is one that's happening these days, and this is one of the attacks they'll do. So there's this attack. You're just going to slow feed a post with a content length, and then just never deliver that content length, and do that with multiple connections. There's another attack, which I'm not even going to attempt to demo. I was never going to attempt to demo, so let's get into safer territory here. Way back in the beginning of the semester, I think we ended up covering day 2, we talked about TCP. Somewhere in here. Right here. No. Right here. No. Right here. Hey, there we go. We talked about TCP. And to establish a TCP connection, we have this TCP three-way handshake, where the client is going to send a SYN message, which is a random number. The server is going to take that random number, send it back +1. So it's going to read the number, add 1 to it, and then send that number +1. And it's going to send its own SYN back, another random number. And the client's going to send an ACK, which is that number that the server sent +1. So it's simple math, it's just adding 1, but what it does is gives both sides of the connection reasonable, beyond reasonable doubt that the other side speaks TCP and that this is an actual TCP connection that we're having here, because they knew how to get M out of the SYN pack, add 1 to it, how to create an ACK pack. It proves that both sides are actually speaking it. So you're not sending TCP ACK messages to somebody who doesn't speak TCP, and then they send back like an HTTP response. That doesn't make sense, but a UDP response, and then you think that that's a TCP response, and then you're both talking 2 different protocols. Things get messy. So it's not a guarantee, but a reasonable assurance that both sides are speaking TCP. Very useful thing, and this happens every single time a TCP packet TCP connection is established. We're using libraries to do that. Your socket server library, the socket library that I just imported, that's what it's doing, is doing either end of this three-way handshake and then getting a stream of bytes of two-way communication sent back and forth. What an attacker is going to do is send this SYN packet, and then that's it. They just send the SYN packet. But they send a whole mess of them. They send a lot of SYN packets and never listen for this response. So what the server is going to do is get this SYN, compute their SYN, compute the ACK, send that back, and then devote some resources to waiting for the ACK, the last ACK packet, which is never going to come. So the server is devoting resources to wait for all these ACK packets that are never going to come, and again, they're going to have some timeout. So whatever that timeout is, that's a parameter that can be adjusted to limit the effectiveness of an attack like this. But it's going to have to wait at least some amount of time because legitimate users might have slow connections, or they might be on the other side of the planet where it's going to take hundreds of milliseconds to get that response back. So they have no idea how long this SYN took. Like, they have no information about how long this took to get there. They have no idea what T0 is here. So it's not like they can measure that. They just send this off and then wait for the ACK to come back. So this is what's called a SYN flood attack. You just send tons of SYN packets to a server, and that's it. Flood them with SYN packets. They devote their resources to opening all these connections and waiting for the ACK packets that never are going to come. SYN flood attack. So that's another attack. And you can think of the whole, like, there's a lot that goes on to creating a connection. After the TCP connection, there's also the TLS handshake. So there could be, it'd have to devote more resources on the attack side, but they could get somewhere in that handshake and then just stop. If they just stop a connection, your servers have to detect that and then sever that connection after, either a timeout, a certain amount of time, or by right on time. It's like we planned this. Or, oh no, that was 4 minutes ago, so maybe not. Or you can check the IP address. So one big line of defense here is, well, if you're getting a bunch of SYN packets like that, or a bunch of HTTP requests with content length that you're buffering, but they're all coming from the same IP address. Like, it's the same IP address launching all these attacks. Take that IP address, put it in your firewall rules, block all traffic from that IP address, done. A few things with this, because obviously it's not that simple, or else we would have no headlines that say DDoS attack, successful, took out GitHub for 2 minutes, or however long the outage was. I think that was 2018 GitHub got hit. But those headlines would never exist if it were quite that easy. So a couple of things. One, your IP address is just a header. Part of the IP headers, it's just a header. It's a sequence of bytes that puts your IP address in there, which is written by software on your machine. Guess who controls software on your machine? You do. You can just spoof your IP address. You put different bytes there. You put somebody else's IP address there. Done. Yeah? I don't know exactly what that's doing, but Cloudflare is at least one of, if not the leader in DOS protection. So they are doing something that's probably pretty sophisticated. I don't know 100% what they're doing, and I'm sure I would guess that they keep that secret pretty locked down, or else people are going to reverse engineer it. But they are doing something. I just don't know what it is. Because there are ways to detect IP spoofing. Again, it's beyond my knowledge, beyond what I know. But you can send different bytes here. If, for example, you control routers, if you're an ISP, I think it'd be pretty easy to detect IP spoofing. Unless you're spoofing, like you're using your neighbor's IP address, that'd be tough to detect. But if you're using an IP address from another country, I think that's going to be pretty easy to detect if you have the right access to things. But on the surface, you just change those bytes. On the surface, IP spoofing is super easy. In theory, I guess. You might have to get down into to some source code pretty deep in your machine. But if you're in a, how do I want to say this? If you're a sophisticated enough attacker to the point where you're, say, rolling your own Linux distros, you have access to all that source code. You can just go to that code and just change it, change what it does, and write whatever you want to happen there. We have access to an open source operating system. You can do what you want. You can do whatever you can code. So that source address is changed. This gets a little more scary too when if somebody wants to launch a DOS attack. So here, let me paint you a picture. I'm an attacker. I'm going to spoof my IP address, send all these attacks at a server. My IP address gets put on a firewall block list, and I can't access that server anymore, right? So I changed my mind. Okay, I'm not that kind of an attacker, right? I don't want to take down the whole server. I just want to take down that server for one user. I spoof my IP address to the IP address of that user. My neighbor's really pissing me off. I get their IP address. I put that, which your home IP address doesn't change. Like on campus, your IP address changes all the time. I get my neighbor's IP address by some means. It shouldn't be too difficult to get. I get my neighbor's IP address. I set my IP address to their IP address, spoof to their IP address, and then I launch a DOS attack on their favorite site. Now they're on that block list on that firewall, and they can't use that app. So if I want to target a single user with a static IP address, I can get them blocked from any site. I mean, I haven't tried. I don't know if I can, but the tools are there. The capability is there if that's how they're blocking, if they're blocking by IP address. But in your attack, in the attacker's attack, you generate random IP addresses, and then each time you send a request or send a SYN packet, it has a different IP address, different port, and then you just launch a whole bunch of attacks like that. So the fact that you can play around with these headers and that they're just ones and zeros, they're just wavelengths in the air, they're just high and low voltage in a wire, they're just light and dark in fiber. We can take advantage of that and just change whatever we want. Hopefully not for malicious things. But knowing that on your server side, when you're building these apps, knowing that, hey, what have I said all semester? Never trust your user. They can spoof anything. Anything can be changed. You get a bunch of ones and zeros over a wire. Don't trust anything of that. Verify everything, because it might be an attacker spoofing all kinds of stuff. And all of that, everything we talked about, is DOS. But the requests on here, 442, I haven't even talked about DDoS or DDoS. So what DDoS is a lot scarier and a lot harder to protect against. It's a distributed denial of service attack. So everything we talked about was just one person launching an attack. A distributed denial of service attack is a whole bunch of machines launching an attack. So you use the same attack methods, but you have a whole bunch of machines launching those attacks. So what do? You get on the old telly and you say, hey, we're going to do this. And then you have a whole bunch of people, a big phone tree. No, you don't do any of that. But you have a bunch of people launch their scripts all at the same time, right? No, I mean, maybe that happens sometimes. Probably happens a lot, I guess. But not the effective attacks. The effective attacks have a very scary thing called botnets. So I don't know if you've ever even experienced this, what I'm about to say, not botnets. You've experienced botnets. You probably haven't known it. But I hate whenever I say this, but back in my day, we had things called computer viruses, right? And the computer virus would take down your computer. Maybe you still experience that these days. I don't know. But you would get infected with a virus, and the virus would destroy your machine. It would brick it or just put it in a state where you had to reinstall your operating system. It would just completely destroy things. And those kind of have gone away. Like, that doesn't happen very often. And we like to think some nice positive things like, well, maybe our software is better where it's not vulnerable to those attacks. Maybe the attackers just gave up. Maybe they stopped writing viruses. No, neither of those. It's that they realize that there's nothing to gain just by bricking your device. What they do now is, instead of viruses, now we call it malware. It's a little bit different. The malware infects your machine and just runs in the background and does the bidding of the attacker without you ever knowing. It's more of an effective parasite now, where it doesn't kill the host, it just uses the host's resources, which we might all have malware installed on our devices right now. It's hard to, the ones that can be detected, maybe you don't have those, but the most latest sophisticated ones probably are avoiding detection. So what the malware does is just sits there and does the attacker's bidding, and when the attacker wants to launch a DDoS attack, they run a script, sends the signal out to their botnet, which is any infected device infected with their malware, and then all those devices, all our devices, launch the DDoS attack. And now how the hell do you prevent that? Because it looks like I'm just accessing the site now. It just looks like a whole bunch of people are using the site and your traffic went up. Great, people are using my app. I'm happy. But it's actually just a DDoS attack and they're trying to take me down. Those are the scarier ones. Those are really hard to prevent, and those are the successful ones that make headlines. Where this gets even scarier is it's not that I've tried, of course, but reading up on it, it makes sense how I would do it and how it would be pretty easy, is we have something new that you're all familiar with. The Internet of Things has become very popular lately. And the Internet of Things, when companies build these Internet of Things devices, very small, cheap devices oftentimes that have, importantly, an internet connection, they usually don't have the best security involved. If you're going to try and sell a $20 IoT device or like a $10 smart light bulb or something, how much are you going to invest in your security practices? So what a lot of these devices have is a default username and password and an IP address. And then just like how other attacks, I forget what exact examples I gave this semester, are launched, you have an attacker who's scanning IP